Okay, so we left off last week, talking about slopes and slope-intercept graphing, where we had equations like, come on, y equals 2/3 x minus 4. And when we graph that, we started at the y-intercept. Now remember, there's two pieces of information in this equation. The number that multiplies the x is the slope. That tells us what to do after we've got our starting point. The other number is that y-intercept. That's our starting point. So we start from the center of our graph. We go down 4 spots. That's where we're going to start this graph. The slope tells us what to do from there. What are we going to do from there then? We're going to rise 2 over 3. Perfect. And then, of course, we looked at equations where we had to do some work to get it into that form. So we had some equations that might start out looking like 3x plus 4y equals 8. And we have to get it into that form of y equals. So we have to get rid of what first? The 3x. Very good. We're going to subtract the 3x. So the 3x is gone. We have the 4y equals 8 minus 3x is 8 minus 3x. And then we just have to get rid of the 4. And how do we do that? Divide by 4. Perfect. So the 4 is gone there. So what's left over there is y. Now, if you recall, we talked last week about when we add or subtract, we only have to add or subtract from one piece on each side. When we multiply or divide, we have to multiply every piece on each side. So we divided this side, only had the 4y, so we divided that. On this side, we have to divide the 8 by 4, which is 2. But then we've got the negative 3x that's also divided by 4. And when it doesn't divide out evenly, we just turn it into a fraction. Negative 3 divided by 4 is negative 3/4 x. So where do we start when graphing that one? Positive 2. Good, right there. From there, then, we go down 3 and over 4. Perfect. Because it's a negative slope, that means we go down instead of up. But our run is always left to right. Well, for today, I want to change our focus just a little bit. I want to go in the other direction. So when we have a graph that looks like this, can I write that equation? Well, to do the equation, there's two pieces of information I need to be able to pull from that graph. One is the y-intercept. And remember, the y-axis is just this up and down axis here. When we graphed our equations, we started at the origin and we moved up or down on that axis to find our starting point. So this line here on that axis starts at -1, -2, -3, -4. So our y-intercept is -4. The second thing we need to be able to find is our slope. The slope, the symbol we use for slope is the letter m. And we have to find 2 coordinates on the graph. And we have to follow from one point up and over to the other. So from this point, we go up and over to get to that point. How far do we rise here? 4 units. How far are we running here? 3. Good. Now we'll double check that is a positive slope. As we move left to right, that line does go up. So that is a positive. The rise is 4, so positive 4 over 3. So the equation for this line, it's y equals the slope times x, so that's 4/3 times x, and then plus or minus the y-intercept. The y-intercept's a -4, so that's -4. Would be the equation for that graph. We might have a line that looks like this. So as we go to graph this, again, what is the y-intercept here? Where does this line cross that y-axis? So, careful. 1, 2, 3, 4, it's 5. You had the right idea. I knew where you were going with it. For the slope then, again, this one has the 2 coordinate points on the axes. Going left to right from this point to the other, we're going like that. What is my rise here? It's 5 units, but it's not 5. It's actually -5. Good, because we're going down. What's my run here? 2. Good. So the slope is -5 over 2. So the equation for this one is y equals slope times x. So it's -5 over 2 times x. My y-intercept's a +5, so +5. How about for a line that looks like this? So we can see our second point is not on one of the axes. We do have our y-intercept, which is going to be what? 3. Very good. 1, 2, 3. To get from this point up to the next grid point, it is rising how much? 1, and it is running 4. Very good. So that gives it a slope of a positive 1/4. So the equation, y equals the slope times x, so 1/4 times x. It's a +3 y-intercept, so +3. You might recall we found the slope of lines given the points. So we might have had a coordinate point of 7, 2, and 3, 12. If I want to find the slope, if you recall, the slope, abbreviated M, is y2 minus y1 over x2 minus x1. Now, if you're wondering what y2 and y1 are, think of these as being 0.1 and 0.2. y2 is the y-coordinate of 0.2. So here's 0.2, the y-coordinate is 12. Minus y1, we go to 0.1, and the y-coordinate is 2. So 12 minus 2 is 10. x2 Well, 0.2, the x-coordinate would be somebody's starting to say there, 0.2, the x-coordinate is 3, minus x1 is going to be what? The 7, good. 0.1, the x-coordinate is 7. 3 minus 7 is a negative 4. Now, we can't just divide this out and get a negative 2.5. We do have to simplify it. First of all, I'm going to put the negative out front. It's a positive divided by a negative. It's going to be a negative. Both 10 and 4 can divide by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. So that is a slope of a negative 5 over 2. So if I give you a point, negative 5, 3, and 7, negative 6. If I want to find the slope, where do I start? What's the first number that's going to go in here? Negative 6. Good. If I think of this as 0.1 and 0.2, negative 6 is the y-coordinate of 0.2. Then we're going to subtract. What's the next number? 3. Very good. That's the y-coordinate of 0.1. What goes in first down on bottom here? 7. Good. The x-coordinate of 0.2 minus negative 5. Good. So one top. What is negative 6 minus 3? Perfect. What is 7 minus a negative 5? Perfect. Now to reduce this, I put the negative out front again. Both 9 and 12 can be divided by what number?
3.
3, good. 9 divided by 3 is 3. 12 divided by 3 is 4. So a negative 3/4. So we can find the slope from 2 points. The next thing I want to do is if I just give you the slope, let's say I give you that the slope is a negative 1/2, and I give you the y-intercept, so we don't even have to find the y-intercept from the graph, is 5. That equation, of course, would be what? Y equals, what would go first?
5 times negative.
Not times negative, but subtract 1/2 x. That works. Y equals 5 minus 1/2 x. That works fine. Another more standard form that many of you might be more used to would be to do the slope first. Negative 1/2 times x, and then plus 5. Either one of those is fine. This is just the more common way of seeing it. So what if instead of telling you the y-intercept, I tell you that the slope is 2/3, and the line goes through the point 6, 1. And I want to find the equation of that line. Well, I know that this equation is going to start out as y equals the slope times x. So y equals 2/3 times x. But I don't know what the y-intercept is. So typically we use the letter b to represent the y-intercept if it's unknown. To figure out what that y-intercept has to be, what b has to equal here, we use our point. This point is telling me that x is 6 when y is 1. So what number goes in for y here? Careful. That's the 1, right? Then 2/3 times x is going to be the 6. Now to solve to figure out what the b has to be here, 2/3 times 6 is 4. And now to solve for b, the last thing we need to do is subtract. It's 4 plus b, so we got to subtract the 4. 1 minus 4 is -3 equals b. So if b is -3, we come up here and replace this b with 3. So that equation becomes y equals 2/3 x, and -3 is the y-intercept, so -3 is what that equation becomes. Let's try another one like that. Let's say our slope is, let's do a -1/2. And the line goes through the point 4, 2. So to start out my equation, it's going to be y equals what's going to become first here? Perfect. -1/2 times x. And then for the y-intercept, we're just going to put in plus b because we don't know what that y-intercept is yet. So now we're going to put our point in here for x and y. What number goes in for y?
2.
The 2. What number goes in for x? 4. So we can combine here. The 2 isn't going to change. -1/2 times 4 is negative. There you go, -2. Perfect. Negative times a positive is a negative. 1/2 times 4 is 2. So now to solve for b, what do I have to do yet? Perfect. It's a -2, so I do have to add 2. So 2 plus 2 is 4. B is 4. So I come up here and replace that b with 4. So y equals -1/2 x. B is a positive 4, so that's plus 4. So y equals -1/2 x plus 4. I want you guys to try one, see if you can get this. So if I give you that the slope is 3/4, and the line goes through the point 8, 10. Find the equation of that line for me, quick. I'll give you a couple minutes. Okay, let's take a peek at how you're doing here. Okay, y equals 2/4 x plus 16, you say? Okay, let's check her out. Let's see if that's what we get. So y equals 3/4 x plus b. And to find b, What goes in for y? 10. And of course for x is 8. So then we've got 3/4 plus 8, or 3/4 times 8 is 6. To solve for b here, we have to subtract 6. 4 equals b. Looks like you added 6 instead of subtracted 6. So it's not quite right. But that's okay. You were close. So y equals 3/4 x plus 4. You had most of the process down. That's the start. Okay. So then the next step we can take is, what if, instead of being given the slope and 1 point, what if we are given 2 points? So I tell you that the line goes through both of these points, 3, 7, oops, and, wow, I can't do it. And the point 9, 3. Well, I'll argue that this is not that much different than the problem we just did up above. Because when we have 2 points, we have the slope. So the slope of this, what's going to go in here first in our formula? Perfect. Point 2, the y-coordinate is 3, minus, what's going to go in here next? 7. Perfect. What is 3 minus 7? -4. Perfect. What's going to go down here? 9 minus this 3. That equals 6. Good. So what does that give me for the slope?
Well, first, you're going to have to put the negative sign first, just like you did.
Perfect.
By 2.
Good deal. So that gives us...
Then you get 2 and then a 3.
Perfect. So our slope is negative 2/3. So we can start out our equation as y equals a negative 2/3 x plus b. Now to find b, last time we used a point. Well, here we have 2 points. So the question is, which one do we use? And the answer is, it really don't matter. We can use either one. So let's just use the first. In this equation, I'm going to do each of them. I'm going to do it both ways just to show you that I get the same answer either way. So for the first time through here, I'm going to use equation, or the point 1, the 3, 7. So y is going to be the 7. And x, of course, is 3. So now we have negative 2/3 times 3. Negative 2. And then?
Well, you're going to add 2.
Perfect. We add 2. So 9 equals b. Perfect. So y equals negative 2/3 x plus 9. Now what if I had used the other point? The 9 and the 3? Well, then the 3 would go in for y. And the 9 would go in for x. And the first step we'd have to do is negative 2/3 times 9 would be negative 6. Negative 2 times 9 is negative 18, divided by 3 is negative 6. Then, of course, we still have the plus b. To solve for b, what do we have to do? Add 6. So once again, b is still equal to 9. So that gives the same result. So it doesn't matter which point we decide to use to find the y-intercept. So if we have that our line goes through -2, 5, and 4, 8. Tell me what to do first to find my equation.
Well, you're gonna do the whole 8 minus 5.
Okay, good. We're finding the slopes. Yes, it is 8 minus 5.
And then that's we divide by 4 minus 2.
4 minus -2. Good. 8 minus 5 is
3.
3. 4 minus a -2?
6.
6. Good. And then, of course, that reduces by, divide by 3, because it's 1/2. So that's our slope. And of course, that goes into our equation as y equals 1/2 x plus whatever b is. Which point do you want to use? Personally, I don't like working with negatives. I would probably pick the 4, 8. Again, it doesn't matter. They'll both give us the same result. So what's going to go in here for y? 8. And for x? 4. So we have 1/2 times 4 is 2. So 8 equals 2 plus b. And then?
Well, then we gotta subtract 2.
Let's subtract 2. Good. So 6 equals b. So the equation is?
Y equals 1/2 times x plus 6.
Perfect. Beautiful. Oops. So if I give you an equation, y equals 2/3 x plus 1, and I ask, is the point 9, let's see here, 7 on that line? How would I test to be sure that that point was on the line? Well, what I could do, you're thinking slope, but I know where you're going. What we can do here, we just have to tell if that single point is on that line. We put those numbers in for x and y and see if it makes the equation true. So which one would go in for y? 7. Then 2/3 times 9. So then what's our next step? Perfect. 2/3 times 9 is 6.
And then we're going to subtract 6. 6 and 7.
Well, you don't have to do that because this is a number here. We just combine 6 and 1 makes 7. So 7 equals 7. Since that's true, this point is on that line. So yes, the point 97 is on the line y equals 2/3 x plus 1. So that's all we needed to do there, was see if we get the same number on both sides of the equation when we put that point in. So is the point -4, 2 on the line y equals negative 1/2 x plus 1. Tell me what to do. Perfect. We put the 2 in for y, the negative 4 in for x. This becomes negative 1/2 times negative 4 plus 1. What's next? Perfect. Negative 1/2 times negative 4 is positive 2. Then what?
It's not on that line.
It's not on the line, is it? We add 2 plus 1 and we get 3.
1, which is 3. 2 equals 3.
2 does not equal 3, so that is not on the line. Now, if I ask you to find the slope and y-intercept from an equation, y equals 3/4 x plus 5, it's pretty simple. The slope is 3/4, perfect. That's what multiplies the x. And the y-intercept was? 5. But it's a little more difficult if I give you the equation 2x minus 5y equals 5. Now we could rearrange this, solving for y, by doing what? We subtract the 2x. So negative 5y equals 5 minus 2x. And then what? Divide by the negative 5. So y equals, so 5 divided by negative 5 is negative 1.
0.
Negative 2x divided by negative 5. Well, first of all, positive or negative? Positive. 2/5, good. X. So what's the slope of that equation? And the y-intercept? Negative 1. Wonderful. But that's a little bit of work to get to that slope and y-intercept. There is a way to find those right out of that equation. Remember back a few weeks ago, we solved literal equations with letters in them? So if I have ax plus by equals c, and I am solving this for the y here, I do the exact same steps I just did up here. I subtract the ax. That would be gone. Minus ax here. So I'm left with by equals c minus ax is c minus ax. I still have to get y by itself. So I'm going to divide by b. Perfect. So now I have y by itself. C divided by b is going to be c over b. Negative a divided by b will be negative a over b times x. So the y-intercept, if the equation starts out like this, is just c divided by b. The slope negative a over b. So if I have an equation 5x plus 2y equals 8, the slope, both the 5 and the 2 are positive, so it's negative, it's the opposite here of a, would be negative 5. What's b going to be? The 2, right? A and b are the numbers that multiply x and y. So the slope is negative 5 over 2. The y-intercept was c divided by b. So c is this number, that's the 8. B multiplies the y, that's the 2. 8 divided by 2 is 4. So we can find the slope and the y-intercept right from that equation. So 4x minus 2y equals 6. I want you guys to find for me the slope and y-intercept if you want. I'll give you a minute in your notes to find those. So, again, this is A, B, and C. The slope is the negative of A over B, right? Well, A is 4, so the negative A would be negative 4. Over B is negative 2, good. So that divides out to be a positive 2 or 2 over 1 if you like to leave it as a fraction. Y-intercept is C over B. C is 6. B is, again, negative 2. So that gives us a y-intercept of negative 3. Good. So if I wanted to graph one of these equations, by the way, this is called the standard form of an equation. Some books would call this a modified standard form. Some books would say that the standard form really is 4x minus 2y minus 6 equals 0. The standard form has to equal 0. To me, this is just fine as the standard form. So anyway, let's say I want to graph one of those equations. So I give you the equation x plus 3y equals 6. Of course, to graph this, the first thing I need to know is my y-intercept. What's that going to be? Well, ABC, remember y-intercept is c divided by b. So that is 6 divided by 3, which gives us 2. So our y-intercept is 2. We start at 2. Our slope is the negative a over b. Well, there's no number in front of the x here, so what does that mean a is? 1. Perfect. So negative a is negative 1 over b is 3. So it's a negative 1/3. So from my starting point, I go perfect, down 1 and over 3. Let's try this one. 3x minus 2y equals 2. So our y-intercept, this is A, B, and C. Our y-intercept is C over B. C is 2, B is negative 2. So that is negative 1. So we start out at negative 1 here. Our slope, opposite of A over B, or negative A over B. A is 3, so negative A is negative 3. B is negative 2. So that's a slope of a positive 3 over 2. From this point, where do we go? Up 3 over 2. Very good. So there's our line. So you can see there are all sorts of relationships between these different types of equations and their different forms. So before we take our break, let's do just a few to review here. The equation for this line. So we're going to start as the slope times x and then their y-intercept. What is the slope of this line? What's my rise? It's 2 and we're going down, so technically it's a negative 2. And our run, 3. So the slope, negative 2/3. So y equals negative 2/3 times x. And my y-intercept is at positive 2. So that's plus 2. So that equation becomes y equals negative 2/3 x plus 2. If I tell you that a line has a slope of 3/4 and goes through the point negative 8, 1. To find the equation, y equals, I start out with my slope, 3/4 x plus, I don't know my y-intercept yet, so I'll put b there. Then what do I do? Perfect. Perfect. Put the 1 in for y and the negative 8 in for x. And then? Three-fourths times negative 8 is negative 6. Then what? It's a negative 6, so we add 6. 7 equals b, so that means plus 7. Good. Y equals 3/4 x plus 7. And of course, the last one we did, if I told you the line goes through 2, 7, and 6, 5, our first step was to find the slope by doing what? Five minus 7 over 6 minus 2. 5 minus 7 is negative 2. 6 minus 2 is 4. So that is, put the negative out front, divide both numbers by 2, so negative 1/2. And it sounds like it's break time there, so I'll let you guys take your break and we'll finish this one up when you guys get back in. So let's shoot for about 2:49. Okay, so here we go. We just found that this slope is a negative 1/2. So we start out y equals negative 1/2 x plus b. And of course, we finish that off by doing what? We pick either one. It doesn't matter. So which one are you going to take? 6, 5 works for me. So y is going to be 5. And x is going to be 6. So we have negative 1/2 times 6, which is negative 3, good. And then add 3, wonderful. 5 plus 3 equals 8, so 8 equals b, which means y equals negative 1 over 2x plus 8. Okay, well now we've seen two forms of equations for these lines so far. We've seen graphing form, which is often called slope-intercept form because it shows you the slope and the y-intercept. That was y equals like 3/4 times x plus 2. That is a graphing form or y-intercept form. We have seen standard form. The standard form was where we might have 3x minus 4y equals negative 8. That's standard form. Next, we're going to look at something called point-slope form of an equation. Point-slope form is mainly invented to make it really easy to write the equation when you're giving information like we've been in the last couple of examples, or to make it really quick or easy to graph an equation when you're not given, you don't have access to the y-axis, so you can't get to the axis, you're away from the origin. What the point-slope form does is it says, I can graph any line by starting at a point. If I say that the graph goes through the point 7, 3, so that's 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. There's the point 7, 3. And it has a slope of 1/2, 1 over 2. So from that point it goes up 1 over 2. I can graph that line. I didn't need a y-intercept. All the y-intercept really does is gives me a starting point. So the point-slope form of an equation is y minus y1 means just a point y times the slope, we use m to symbolize the slope, times x minus x1 is the point for x. So if I'm looking at this equation here, the slope from up here is 1/2. So m is going to be 1/2. y1 is the y coordinate of that point, that's the 3. So it's going to be y minus 3. Over here, x1 is the x coordinate of that point, which is 7. So this will be x minus 7. So just that quickly, we constructed an equation for that information. So I'm going to look here at an example, and I'm going to do it this way, and then I'm going to do it the way we did earlier in the first half of the class. Then we're going to do some little adjusting to our equations to show you that they really are the same equation. So let's say we have an equation that has a line with a slope of a negative 3/2, negative 3 over 2, and it goes through the point 6, 3. So using what we just learned with point-slope form of an equation, we can make this equation really quickly. What goes in for y1? The y-coordinate of our point, right? The 6. Equals what goes in for m? Slope. Perfect. The slope of negative 3/2 times x minus what goes in for x1? I screwed up here, didn't I? This should have been the 3, shouldn't it? Yep. So for x1 would be the 6. So there's our equation. That's not in Y-intercept form, but it's not hard to change it into Y-intercept form. But let's go ahead and write our equation in Y-intercept form like we were before. Then I'll show you that they're equal. So this equation would start out y equals negative 3/2 times x plus b. So to find b, what's going in for y? 3. And for x? 6. So negative 3/2 times 6 is negative 9. You are correct. Plus b. Then what do? Add 9. So 12 equals b. So this equation is y equals negative 3/2 times x plus 12. Well, let's show that this equation here is the same as that. To do that, I've got the parentheses here with the negative 3/2 outside. I'm going to multiply by the negative 3/2. So negative 3/2 times x is negative 3/2 x. Negative 3/2 times negative 6 is a positive 9. So I've got y minus 3 here. The only difference between this equation and this one right now is the minus 3 there. How do I get rid of that minus 3? I'm going to add 3. Now remember, when we add or subtract to an equation, just one piece on each side. So I can add the 3 there to get rid of the negative 3. There's y. I'm going to add 3 on the other side just to the 9. So the negative 3/2x stays the same. 9 plus 3 is positive 12. So y equals negative 3/2x plus 12. So both of them are the same equation, just different forms. This point-slope form, however, like you see, is really quick and easy to put the points in. Okay, so let's say our slope is 2, and the point goes through the point, or the line goes through the point, negative 8, negative 1. So when we go to put this in point-slope form, remember point-slope form is y minus y1 equals m times x minus x1. So we got to put in the negative 1 goes in for y1. So this is going to be y minus a negative 1, which is going to become what? Plus a positive 1. Good. Over here, m is the slope. That's 2. We've got x minus x1. Well, x1 is negative 8. So this is going to become minus a negative 8, which is going to be plus 8. Good. So there is the point-slope form of that equation. Well, what if I gave you 2 points? Find the point-slope form of the line that goes through 6, negative 1, and 9, negative 3. Well, the first thing we need to have here is the slope. How do we find the slope from those 2 points? Minus negative 1. Okay, what does that give us?
Well, we're gonna get a negative 2.
Negative 2, good. Then on bottom, what do we have?
9 minus 6 equals 3.
9 minus 6 equals 3. So we have a slope of a negative 2/3. So now, to finish the equation, we can use either point. It really doesn't matter. So we're going to get 2 different equations here. Remember, y minus y1. Let's use this point first. So what's going to go after the negative here? Well, y1 is going to be what? Negative 1. So this won't even be y minus. It's going to be y plus 1. Equals, what's going to go next? Negative 2/3 is my slope. And then in the parentheses, x minus x1. x1 is 6, so that'll just be minus 6. Now, if we'd use the other point, this would look a little bit different. Y minus y1. Well, y1 is negative 3. So minus a negative 3 is plus 3. What's next? Negative 2/3 times x minus 9. Good. Now these don't look much alike, but they really are the same equation. Let's show that here quick. So on this one, I'm going to multiply by the negative 2/3. So negative 2/3 times x, negative 2/3 x, negative 2/3 times negative 6 is a positive 4. So to make this into Y-intercept form, all I have to do is subtract the 1. So y equals negative 2/3 x plus 3. On the other side over here, I'm going to multiply by distribute the negative 2/3. Negative 2/3 times x is again negative 2/3 x. Negative 2/3 times negative 9 is positive 6. And to finish that off, all we have to do is subtract 3. So we get the same equation, either way. Okay, now we do have a quiz coming up here to finish the hour. I'm going to give you the homework assignment here quick. So this is in the big book. On page 404 through 405. Exercise 16-7A. Page 402, exercise 16-5. Page 403, exercise 16-6. And page 406, exercise 16-7B. So that's your homework. Like I said, there is a quiz coming up, but then also on Friday is a unit test. So that unit, what's that?
I'll scan you. I said they've corrected their quizzes today from the ones you sent me, so I'll scan those back and email them back to you either today or tomorrow morning.
Perfect.
So what the plan with the quiz or the unit test on Friday? Will they have some class period to do that as
Yeah, what I plan on doing is I plan on taking maybe like the first 30 minutes or so to do a review. Then I'll give them the last hour to work on the test. I don't anticipate an hour might not be quite enough to finish it. So since we have that following week off for spring break, if you need time to fill in time for them to have them finish it up in class, that would be wonderful. But
With the unit test, is the expectation basically no talking? I just need to know if I need to like separate these guys a little bit so they've got a little bit more room to move so they're not chit-chatting a little bit, or is it kind of, what are your thoughts on it?
on the unit test, I don't mind if they bounce ideas off of each other, just as long as they're not looking at somebody's paper and just blindly writing down answers.
Okay. Okay, I'm cool with that too.
Okay, sounds good. Okay, so if you want to hand out that quiz for him, Mr. Berghammer.
All right. Thank you.
You bet. Thank you.